Alright, let's talk about a job that's anything but simple. We're out here on the open water, on a massive vessel that needs to stay perfectly still, while a storm could be brewing just over the horizon. This is DP2 offshore operations. Before we even think about pushing a single button, the real work begins. It's the unglamorous part of the job, the part that doesn't make for exciting television, but is absolutely the most critical. It all starts with planning. You have to think about everything that could possibly go wrong, because out here, wrong can happen fast and have serious consequences. We're talking about looking at every angle, every potential risk, and having a solid answer for it before you leave the dock. It's the homework that keeps everyone safe. This planning phase is all about paperwork, and lots of it. First up is the risk assessment. You and your team huddle up and brainstorm every conceivable hazard. What if a thruster fails? What if we lose a GPS signal? What if the weather turns nasty quicker than the forecast predicted? You write it all down, and more importantly, you figure out how to manage it. This isn't just bureaucracy for its own sake, it's a playbook for survival. Then you move on to the checklists. These are your best friends. They ensure you don't miss a single step, from checking the fuel levels to confirming the operational limits of the crane you might be working with. It's tedious, but skipping a single checkbox could be the difference between a smooth operation and a very bad day. Next on the list is the weather. Mother Nature is the ultimate boss out here, and she doesn't care about your schedule. You have to become a bit of a weather nerd. You're constantly checking the forecast, not just for today but for the next few days. You're looking at wind speed, wave height, and the direction of the swell. You need to understand how these elements will affect the vessel's ability to hold its position. A forecast for deteriorating weather might mean you have to set stricter limits on your operation, or even postpone the job entirely. Ignoring a weather warning is like playing Russian roulette with a multi-million-dollar piece of equipment, not to mention the lives of your crew. Finally, it's about making sure all your documents are in order and everyone knows the plan. This includes things like the field layout, the project procedures, and the SIMOPS plan if other vessels are working nearby. Everyone on the bridge, from the dynamic positioning operator to the captain, needs to be on the same page. You walk through the entire operation, step by step, in a pre-job safety meeting. It's a chance for anyone to ask questions or raise concerns. This isn't a time for being shy. A clear, well-communicated plan is the foundation upon which the entire messy, complicated, and dirty job is built. Without it, you're just guessing, and out here, guessing gets people hurt. Once the planning is done and you've got the green light, it's time to bring the heart of the vessel to life, the DP2 system. Think of it as the ship's brain and nervous system. This isn't like flipping a single switch, it's a careful, methodical process of waking up a complex network of computers, sensors, and machinery. The 2 in DP2 means you have redundancy. In simple terms, for every critical piece of equipment, you have a backup ready to take over instantly if something fails. So, you're not just starting one system, you're starting 2 or more of everything, making sure they are all working independently. This is where you really see the engineering magic that keeps these giants steady in the heaving sea. The first step is initializing the DP computers. These are the brains of the operation. You fire them up and watch as they run through their self-checks. You have a main computer and a backup, and you need to see that both are running perfectly and are ready to take control. Next, you bring the sensors online. These are the system's eyes and ears. We're talking about multiple GPS units, laser-based sensors like size scan, and sometimes acoustic transponders on the seabed. You need at least 3 different position reference systems running at all times. Why 3? Because the system constantly cross-references them. If one starts giving bad data, the system can identify and ignore it, relying on the other 2. It's a high-tech game of one of these things is not like the others. With the brains and senses awake, you need to check the muscles, the thrusters and propellers. These are what physically hold the ship in place, pushing against the forces of wind and waves. Your DP system will test each one, making sure it responds correctly to commands. You check that they can move in the right direction with the right amount of power. The system needs to know exactly what each thruster is capable of. It's like a conductor making sure every musician in the orchestra is in tune before the concert begins. A single thruster that isn't responding correctly can compromise the entire operation, so this check is absolutely non-negotiable. The final piece of this setup puzzle is communication. Technology is great, but it's the human element that makes it all work. The DPO must have clear, open lines of communication with the engine room, the bridge crew, and the team on deck. Everyone needs to understand their role and be able to report any issues instantly. You confirm all radios and intercoms are working. The DPO will announce each step of the setup process, so the entire team has full awareness of the vessel's status. This constant chatter isn't just noise, it's the lifeblood of a safe operation, ensuring that the right hand always knows what the left hand is doing. It's teamwork in its purest, most essential form. Now that the system is awake and purring, it's time to get to the real business. Holding the vessel in a precise spot, sometimes with only a meter or two of wiggle room, hundreds of miles from shore. This is where the DPO's skill truly shines. The first decision is selecting the right operational mode on the DP system. You might start in auto position, where the system does all the work, managing the thrusters to keep the vessel locked onto the desired coordinates. This is the most common mode for stationary jobs like dive support or subsea construction. The DPO simply tells the computer where to be, and the system takes care of the rest, constantly fighting the elements. The DPO is now an active guardian, not a passive observer. They must continuously monitor the system's performance. On their screens is a flood of information: the vessel's current position versus its target position, the amount of power each thruster is using, the wind speed and direction, and the status of all the position reference sensors. The key is to understand what normal looks like. This allows you to spot a problem before the alarms start screaming. For instance, if one thruster is suddenly working much harder than the others, it could be an early sign of a mechanical issue. It's a constant, vigilant watch, interpreting the data to stay ahead of any trouble. A crucial part of holding position is having a contingency plan. The DPO will set up what's called a consequence analysis. This feature allows the system to simulate failures in real time. It constantly asks, what if? What if the forward thruster fails right now? What if we lose power to the port side? The system will show the DPO if the vessel could still hold its position after such a failure. If the answer is no, the vessel is in an unsafe operating condition. This foresight allows the team to change the vessel's heading or move to a safer location before a potential failure turns into a real emergency, ensuring the 2 in DP2 is always ready to do its job. Of course, the job doesn't always involve staying perfectly still. Sometimes you need to move along a specific path, like when laying a pipeline or conducting a survey. For this, the DPO might use auto track mode. In this mode, they program a route into the computer and the vessel follows it with incredible precision. The principles are the same: constant monitoring, checking the consequence analysis, and ensuring all systems are healthy. Whether you're standing still or on the move, the goal is control. The DPO uses the DP system as a tool to impose human will on a massive steel structure in an environment that is constantly trying to push it around. Once you're set up and holding position, the job enters its longest and in some ways most demanding phase, the watch. This is hours of intense focus. The DPO and their team are glued to their screens, monitoring every flicker of data. Every event, no matter how small, gets logged. This isn't just for record keeping, it's about building a complete picture of the operation. If a sensor drops out for a few seconds and comes back, it gets noted. If the wind picks up by a few knots, it's logged. This detailed logbook becomes an essential tool for troubleshooting problems, and for the debriefing that happens after the job is done. It's the official story of what happened out there. During this long watch, teamwork remains paramount. The DPO maintains a running commentary with the bridge team and any personnel on deck. Holding steady, all systems green. Wind is gusting to 25 knots, thruster load is increasing. This keeps everyone informed and maintains situational awareness across the entire vessel. It ensures that if something does start to go wrong, the whole team is already in the loop and ready to react. This constant flow of information prevents surprises and makes the response to any issue smoother and faster. It's a culture of communication that is drilled into every member of a professional crew. But what happens when an alarm does go off? This is when training takes over. The first step is to acknowledge the alarm and calmly identify the problem. Is it a sensor failure? A thruster malfunction? The DP system is designed to handle a single failure automatically. That's the core principle of DP2. The backup system should kick in seamlessly. The DPO's job is to manage the situation, confirm the automatic changeover worked, and assess the vessel's new status. If the vessel can no longer safely hold its position after the failure, they will follow their emergency procedures, which might involve safely aborting the operation and moving away from any nearby structures or divers in the water. When the work is finally done, you don't just switch everything off and head for a coffee. The process of shutting down is just as methodical as setting up. You follow a post-operational checklist to the letter. This includes safely recovering any equipment from the water, informing all parties that the job is complete, and carefully powering down the DP system. Then comes the debrief. The entire team gets together to discuss what went well and what could be improved. You review the logs, talk about any alarms or unexpected events, and share lessons learned. It's this final step that makes a good crew great. It's about taking the experience from one dirty job and using it to be safer and more efficient on the next one.